It's time to put together everything we've learned about factoring and then just basically do a whole bunch of factoring problems. Okay, so how to factor. Let's pull it all together. So the first thing you always want to do is factor out a GCF if possible. If there's a GCF, take it out. Always. It makes your problem a whole lot simpler. And then you want to kind of look at how many terms there are left in the polynomial. Are there 2 terms, 3 terms, or 4 terms? So 2 terms, you kind of like to see, because if it's 2 terms, then you just have to judge, was it a difference of squares, a difference of cubes, or a sum of cubes? Remember, sum of squares is always prime, so those one get ignored right off the bat, right? These two, the bottom two, have formulas that you don't have to memorize, they just exist. And then the top one is the easiest factoring you're going to have when you have a difference of squares. It's a plus b, a minus b, done. All right, if it's 4 terms, that's also pretty easy because it's kind of obvious that it's factoring by grouping. And factoring by grouping isn't that bad. You just have to know what you're doing. And then that leads to the 3 terms, the trinomials. They're evil. All right, if a is equal to 1, actually, they're not too bad. Right? If a is equal to 1, you're okay. It's when a is not equal to 1 that you have to break it all down using the middle term and break it up into grouping and all that good stuff. Pretty brutal. All right, and then you keep going. So are any of the things that you've made still factorable? If they are, then you've got to move on and keep doing it. And then if you keep going and going and going, right, until you can't go anymore, once everything left is prime, then you're done. All right, so let's do it. We'll start off with this lovely piece right here, which is 10x to the 4th plus 22x to the 3rd minus 24x squared. Now, a red flag to me right off the bat is that this has a GCF, and we better take it out. So all of these things are divisible by 2. So 2x squared, that would leave me 5x squared plus 11x minus 12. Right off the bat, we got a terrible one because this is a trinomial, 3 terms, and a, the leading coefficient, not 1. Ugh. All right, so let me go grab a table. Hold on. Okay, so we need a times c to be 5 times 12, negative 12 actually. So that was equal to negative 60. So we have negative 60. All right, and we need to add up to b, and b is 11. Okay, so let's think. What are some numbers that make negative 60? 1 and negative 60. Well, that makes negative 59. That won't work. 2 and negative 30. That makes negative 28. 3 and negative, 20. That makes negative 17. 4 and negative 15. That makes negative 11. Oop, that's close. So how about negative 4, positive 15? That'll make positive 11. That's what we want right there. Okay, so that's the combo we need. Let me highlight it. So what I'm going to do with that is I'm going to go up here and break up this 11x into that combo. So it's going to be equal to 2x squared. All right, 5x squared. Instead of plus 11, I'm going to write, let's see, it was minus 4 plus 15. So minus 4x plus 15x minus 12. Now it's factoring by grouping. So I'm going to group together the first 2 terms mentally and look at them and say, okay, what do they have in common? Well, they both have an x. So this is going to be equal to 2x squared. The first 2 terms both have an x. That would leave me 5x take away 4. And the back 2, they both have a 3. That leaves me 5x take away 4, which is good. You need these parentheses to be identical for factoring by grouping to work. All right, so this is 2x squared. And then I can take a 5x minus 4 out from both of them. That leaves me x plus 3. There's an x left in this first term, plus a 3 left back here. And then we're done. And that one took up a lot of space, so I'm hoping the rest of it will all fit in. All right, so next one. Oh, this looks like a mess. 2x to the 5th, y, take away 128, x squared, y to the 4th. Oops, y to the 4th. All right, again, let's take out a GCF and get it out of there. So there's a 2x squared y. Okay, 2 goes into both of these numbers, 2 and 128, so that's obvious. And then remember with the variables, you want to go for the lowest power, because you can't get any more than x squared, because that's all this term has to give. This term only has x squared. So you got to go with an x squared, and then a y, because the first term only has a y. All right, that'll leave you with x cubed, take away 64y cubed. Okay, so that's a difference. See how it's a binomial? So binomial means you want to look for, is it squares or cubes? And it's rather obviously cubes, because it's at x cubed minus 64y cubed. Okay, so we're doing a cubed, take away b cubed, don't forget the formula, is equal to a minus b, a squared plus ab plus b squared. That's the formula. All right, so a for us is x, because a cubed is x cubed. So that means that a must have been equal to x. There's our part for that part. And then b cubed is equal to 64y cubed. So that means that b is equal to 64y cubed to the 1/3 power. Or if you like, the third root, which would be 4y. All right, so I've got a is x, b is 4y, and then I'm just going to substitute in the formula. And you got to keep the 2x squared part in front. So this is 2x squared. And these are just kind of side notes. So I'm going to put them over here because they're not really part of the problem. They're kind of on the side, things that you're figuring out. There we go. All right, so we got 2x squared y. And then instead of x cubed minus 64y cubed, I'm going to write x minus 4y. And then x squared, so that'd be x squared plus 4xy plus, now b has to be squared. So I'm going to take all of 4y and I want to square it. So 4y times 4y would be 16y squared. Don't forget to square the 4. And we're done. Oops. There we go. All right, next. All right, so we've got 24x squared minus 54y squared. All right, again, there's definitely a common denominator here. 2 goes into both of them, 3 goes into both of them, I think 6 goes into both of them. That'll leave you 4x squared, because 6 times 4 is 24, minus 9y squared. There we go. All right, again, we've got a binomial, but this is a binomial that's much easier to deal with because it's squares. So that's going to be 6, and remember, this is the easiest factoring you're going to get. You take the square root of both of these. So 4x squared becomes 2x and 2x. You get a minus and a plus. Right, you're breaking them up to be conjugates. And then 3y and 3y. Because 3 times 3 makes 9, but they're perfectly evenly matched, right? You're taking the square root is what you're doing. Square root of 9y squared. And that'd be 3y and 3y. And then same thing with the square root of 4x squared. That's 2x and 2x. And there we go. Done. Well, that was easy, but not surprising. Binomials, when there's a difference of squares, are easy. D is not going to be so easy. All right, so let's make a table. We need to multiply to a times c. A times c is 2 times 6. And we need to add up, which is 12. And we need to add up to b, which is 9. There was no GCF on this one. That's why I jumped right into the table. Because 2, 9, and 6 there's no common factor to all of those. All right, so we need to multiply to a positive and add to a positive, so that'll be easy. It's positive 1, positive 12. That makes 13. 2 and 6, that makes 8. 3 and 4, that makes 7. And we're done. There's nothing that's going to work here. Because we went from 13 to 8 right there. So this is prime. Cannot be factored. Done. Next. Let's see. All right, so 2 terms, so this shouldn't be too bad. Let's see. We've got a 3x, take away a 3x to the 4th. Okay, so obviously these both have 3x in them. So that would leave us 1 minus x cubed. Now it's up to you. If you don't like this, this direction, you might think to yourself, well, instead of doing out 3x, why don't I take out a negative 3x? That'd be a minus 1 and a plus x cubed. If you like your x cubed, your higher power being positive, that might be a good thing. So it'd be 3x, negative 3x, excuse me, negative 3x times x cubed, take away 1. Not that the other way is wrong so much as we generally like our powers, our highest degree term, to be positive if we can help it. All right, again, difference of cubes. So let's figure out what a is. So a cubed is equal to x cubed. So that's kind of obvious that a is equal to x. And then b cubed is equal to 1. Don't worry about the negative. The negative gets taken care of in the formula, so you don't have to stress about that. So that would mean that b is equal to the 1 to the 1/3, which is 1. And now you have the pieces for your formula. So you can write negative 3x. The formula says you go a minus b, so that's x minus 1. Then a squared, that's x squared, plus ab, so that's plus 1x, so that's x, plus 1. And you're done. And I'm just doing that formula from memory, but you don't have to memorize that formula. You just have to be able to use it. And I'm using that difference of cube formula, this formula right here. That's what I'm using to be able to do this, right? So I just know it by heart. So let me put it in there. There you go. So using that difference of cube formula again, but it's a little bit easier on this one because it's just plain x cubed and plain 1, right? So it was a little bit easier to figure out what a and b were. All right, we're done with that one. Oh, look, it's another difference of cube formula. I can't escape them. All right, so we have 8 minus 27. What was it? Hold on. It was 8 minus 27y cubed, right? Okay, this is obviously a difference of cubes. Again, it's up to you. You can leave it like this. This is fine. Or you can try to switch it around because you don't like the fact that the cubed part is negative. It'll be fine either way. So if you want to switch it around and take a negative out, you'd factor out a negative 1 and then make it 27y cubed, take away 8. That's fine if you want to do it that way, but you don't have to. And just for fun, I'm going to actually not do it on this one just so you can practice the other direction. Okay, so a cubed is equal to 8. So that's kind of obvious. That means a is equal to 8 to the 1/3 power, which is equal to 2. All right, and then we know b cubed is equal to 27y cubed. Those are the harder ones because they've got more pieces to them. So that means that b is equal to all of 27y cubed to the 1/3 power. That would be 3y. Okay, so now I'm going to substitute in the formula. Hold on one sec. Okay, so matter of fact, I'm just going to do it right up here. So this is going to be 2 take away 3y, and then it's going to be parentheses 2 squared, that's 4, plus 2 times 3, that makes 6y, plus, and here's the hard part, you've got to square all of b. So you want to take 3 times 3, that's 9. So it's 9y squared. And all the work for it's down below. But that's how it's going to happen. Just for fun, just so you know, if you'd gone the other direction and taken out a negative 1, that'd have been fine. It would just have been negative 1 in front. Oops, negative 1 times 3w, or so, yeah, 3y minus 2 times 9y squared plus 6y plus 4. Same stuff, but just kind of rearranging the order. So if you take it out negative 1, that's what it would have turned into. And while I'm on the subject, that's also how this other one would have worked. So we came up with negative 3x times x minus 1. If you wouldn't have taken out a negative at the start, then this would have been your answer. Either one is fine, right? Either you take a negative out or don't. You can come up with 2 completely acceptable factored answers, depending on whether you took out a negative at the beginning or not.